Google released their latest Gemma 4 QAT model, which massively lowers the hardware requirements for local AI. I'm talking about the E4B version, 7.46 billion total parameters, with only 4 billion active. This got me thinking, can we actually deploy this model on a low-spec, GPU-less machine and still use it to effectively control smart devices in Home Assistant, like turning a smart plug on and off? To test this theory, I went out and rented a pretty low-spec cloud VPS. It's got a 4-core vCPU and 16 gigabytes of RAM. No dedicated GPU here. Using Docker, I spun up Ollama and pulled down the Gemma 4 E4B QAT model. I did a quick sanity check in the terminal, typing in which model you use. And you know what? It actually ran. But if you check the logs, you'll see the response speed is only about 4 tokens per second, which is definitely on the slower side. But remember, this is a virtual server, not a local bare metal machine. This means your mini PC, NAS, or even a Raspberry Pi used for Home Assistant should be more than capable of running this local model. Alright, now let's bridge the gap and add Ollama to Home Assistant. Thankfully, Home Assistant has a built-in integration for this. You just head over to Settings, click on Devices and Services, and hit Add Integration. Search for Ollama and type in your host address. Since we didn't set up an API key on our local Ollama instance, just leave that field blank. Hit Submit, and we are in. Let's do our first test using the built-in conversation agent. I clicked on Add Conversation Agent, gave it a custom name, and selected our freshly downloaded Gemma 4 model. Make sure you check the box for Assist and enable Think Before Responding to give the model a little breathing room. Then I set up a simple voice assistant using this Ollama agent. I opened the chat window and gave it a straightforward command. Turn off the smart plug with the entity ID switch.smartplugSocket. Because of our low-spec hardware, the loading wheel just spun and spun, and when it finally finished, nothing happened. The plug stayed on. I ran a few more tests, and while it did manage to turn it off a couple of times, it was wildly inconsistent. For such a simple task, not getting a reliable execution is honestly pretty disappointing. But before we write this model off completely, let's see how it handles AI tasks. Back on the Ollama integration page, I clicked Add AI Task using the same settings. This time, I wanted to test its vision capabilities and structured output. I headed over to Developer Tools, selected the Action tab, and chose Generate Data. For the prompt, I typed, describe the image content. If there is a person, output true. If not, output false. I provided a structured output template, uploaded a photo with a person in it, and hit Perform Action. After a brief loading phase, it successfully analyzed the image and returned the exact structured output I asked for. Not bad at all. So the model clearly has some brain power. Why did it struggle so much with basic device control? I decided to test a custom integration we've talked about in my previous video, Extended OpenAI Conversation. This integration has built-in tool support to control smart devices. I set it up, typed in a dummy API key, checked the Use Tools box, and submitted. When I opened a new conversation and sent the exact same prompt to turn off the smart plug, the results were much better. I tested it 3 times consecutively, and it successfully turned off the smart plug every single time. This proved a crucial point. When utilizing this integration, the model is indeed capable of reliably calling and executing tools, showing that the model itself isn't the bottleneck. Since the model can use tools, can we make it execute an agent skill instead? To test this, I had AI write a custom skill for OpenWUI to handle switching devices, along with the matching tool code. I went into WebUI, pasted the skill code, pasted the tool code, and linked them directly to our Gemma 4 model. Now I typed the exact same prompt into the chat, and the smart plug clicked off instantly. I tested it a few times, and every single time it worked without a single hitch. It turns out this custom toolchain method performs dramatically better than Home Assistant's native conversation agent. That was definitely a pleasant surprise. So after a series of highly unscientific and non-rigorous tests, in my personal opinion, this model is still just about usable for controlling devices in Home Assistant. By the way, I've put together a document summarizing everything from this video and all of our past videos. Link in the description. Do you think you'll try running Gemma 4 on your own setup? Let me know in the comments. As always, your likes and subscribes keep me going. Thanks for watching.